Welcome to The Explainer. I am so glad you're here. Today, we're taking an exclusive behind-the-scenes tour of a virtual AI factory. From the foundational blueprints all the way down to the humming engine room, we're going to demystify 26 essential concepts of artificial intelligence. Think of this as your ultimate A to Z glossary explainer. It's designed specifically for focused learners like you who just want to cut through the noise, grasp these complex topics, and truly understand how this technology actually works under the hood. Okay, let's dive into this. Here's our roadmap for today. We'll start with the AI foundations, move into how machines actually learn, step into generative and language AI, explore applied techniques and infrastructure, and finally, look at real-world AI tools. Building complexity gradually like this is really going to help us sort the entire alphabet soup of AI into 5 logical, interconnected buckets.
Section 1. The AI Foundations, the Blueprint of Artificial Intelligence. Welcome to the ground floor, where the foundational blueprints of AI are drawn up.
We've got to start with the letter A, artificial intelligence. Simply put, this is when machines perform tasks that normally require human intelligence. This right here is our anchor term. Literally everything else we're about to explore today is just a method, a tool, or a stepping stone to achieve this one overarching goal of replicating human-like intelligence inside a machine.
Now, what's really interesting about this slide is how these 5 concepts build directly on top of each other. At the top, machine learning, our M, allows computers to learn patterns from data without being explicitly programmed to do so. When you make that highly complex, you get D for deep learning. Deep learning relies on N, neural networks, which are computing models directly inspired by the human brain. And today, the absolute most powerful deep learning models use a specific architecture called a transformer, RT, powering massive modern AI models. And how do all these networks actually know what to predict? Well, that comes down to W, the weights. These are the learned parameters inside the neural network that guide exactly how it makes its predictions.
Moving on to Section 2, how machines actually learn inside the AI classroom. Let's step into the classroom and examine the learning paradigms that actually teach these foundational machines how to process information. First up, we have S for supervised learning. This is when a model learns using labeled data. Basically, it's like handing the AI a complete answer key so it can learn by example. We contrast this with U, unsupervised learning, where the machine has to discover patterns in entirely unlabeled data. Imagine giving a student a giant pile of messy, uncategorized information and just asking them to find the hidden structure without any answer key at all.
And then we have a truly fascinating concept, Z, zero-shot learning. This is the ability of an AI model to perform a task without being specifically trained on any examples for that exact task. It's absolutely incredible. It means the AI can leverage its general, pre-existing knowledge to tackle a completely new, unseen problem on the very first try.
But, the classroom isn't perfect, and we really need to look objectively at what happens when these systems fail us. We face 2 major pitfalls here. First, B for bias. This occurs when an AI model produces unfair or inaccurate results simply because it was fed bad or biased data. Then we have O, overfitting. Overfitting happens when a model just memorizes the training data instead of actually learning the general patterns. Why does this matter? Well, think of a student who just memorizes the answers to a practice test. Sure, they might get a perfect score on that practice run, but if you give them a slightly different exam in the real world, they're going to fail completely because they didn't actually learn the underlying subject.
All right, Section 3, generative and language AI, stepping into the studio. Let's shift gears and step into the highly visible world where AI actually creates new content.
At the very heart of the studio is G, generative AI. This is defined as AI that creates entirely new content. We're talking about text, images, music, videos, or even software code, built completely from scratch. This is the specific branch of technology that has taken the world by storm lately.
So the crucial point is, how do we actually interact with these generative systems? Well, first, we use LLM for large language models, or LLMs. These are massive AI models trained on huge amounts of text so they can understand and generate human language. But to get a truly great result from an LLM, you need P, prompt engineering. This is the art of designing effective inputs, or prompts, to carefully guide the AI and get the absolute best possible responses out of it.
But what if clever prompt engineering just isn't enough? That's exactly where F, fine-tuning, comes in. This is a 3-step process. First, you take a pre-trained AI model right out of the box. Second, you introduce your own highly specific data to it. And third, as a result, the model performs your specific task much, much better. It's essentially like sending a general high school graduate to a highly specialized trade school so they can master a single craft.
However, even in the studio, there are risks. Enter H for hallucination. This happens when an AI model confidently generates incorrect or fabricated information. It's a critical danger in generative AI. The system can act highly confident, presenting you with beautiful, articulate language while being entirely wrong about the facts.
Section 4. Applied Techniques and Infrastructure. Pulling back the curtain on the engine room. Let's head down into the engine room to uncover the complex, behind-the-scenes infrastructure that makes all these paradigms function in the real world.
And this brilliantly illustrates one of the absolute best solutions for those hallucinations we just talked about. It's RAG, Retrieval Augmented Generation, or RAG. It works like this. First, before the AI speaks, it retrieves relevant factual information from trusted external sources. Only then, in step 2, does it generate an informed answer. It essentially forces the AI to look up the facts in an encyclopedia before it's ever allowed to open its mouth.
But how does the AI actually search for and understand all that data so incredibly fast? Well, it uses E for embeddings. These are numerical representations of meaning for text and images. Those numbers are stored and searched inside a V, a vector database. The AI also uses a K, a knowledge graph, which is a structured network connecting information so the AI actually understands real-world relationships. By grouping together embeddings, vector databases, and knowledge graphs, the system can successfully perform I, inference. Inference is the actual act of using the trained model to make a prediction or generate a response right then and there. There are a few more critical tools keeping this engine room humming. C is for computer vision, which enables AI to analyze images and video. We also have X for XGBoost, a remarkably powerful algorithm for prediction and classification tasks. To make these systems efficient, we use Q for quantization, a technique for reducing a model's size and memory footprint without losing performance. And finally, Y for YAML, the human-readable configuration language developers use to actually deploy these complex workflows. Section 5. Real-world AI tools, putting it all together. Let's transition to our final section, focusing on the practical environment where data scientists actually interact with all 25 of the previous concepts.
That brings us to our final letter, J, which stands for Jupyter Notebook. This is an interactive environment for writing and running Python code, and it's widely used across all of AI and data science. You can think of the Jupyter Notebook as the essential interactive workbench. It's literally the physical digital space where human developers write the code to orchestrate everything we've talked about, bringing all this incredible AI infrastructure to life.
And that brings us to the end of our glossary tour. So, now that you know the A to Z of AI, how will you use this vocabulary to shape our AI-driven future? Understanding these terms isn't just about sounding smart, right? It's about having the foundational blueprint to navigate, build, and innovate in a rapidly changing world. Thank you so much for following along on this structured explainer journey. I really hope you're now eager to dive even deeper into the AI ecosystem. Keep exploring, keep learning, and I'll catch you in the next explainer.